This video, I'm just going to talk a little bit about how to tell if this thing's good or bad. Water heater element out of an RV, okay? And so we want to know what the ohms are on these things to see if they're good or bad. That's one way to do it. You can check the amp draw too. But you have to use Ohm's law to figure all this stuff out. So this one's down here is to figure out what the watts are, and this is your Ohm's law up here. So your volts, your amps, your resistance, and then your power, your amps, and your volts. So I don't do this very often, so I never remember this. I gotta look it up all the time. So I came up with a way for me to remember it, so I could do it with other appliances also. And the way I do that is through the water heater element. So if we look on here, somewhere on here, it's going to tell us 1400 watts at 120 volts. See if I can see it better on this one. There's 120 volts, 1400 watts. Okay, so if we know 1400 watts, we divide it by 120 volts. So the way I remember is the higher number goes on top. This is what I mean by that. The higher number goes on top. And then I know this number and this number. So I divide that number into that number, you get 11.6 amps. Now we can use Ohm's law to figure out what the ohms is to that. So we know 120 volts. Once again, 120 volts is the bigger number. So that's how I remember that. The bigger numbers go on top. Volts goes on top. That's just what I use to remember it. So 120 volts divided by the amps gives you the ohms. Okay, we don't know this one. That's why I can say this one goes on top. I know these two. And here I know these two. So water heater element should draw about 10.3 ohms. If you have a 1440 watt element, it's going to draw about 10 ohms. Okay, and you can do the same thing for a refrigerator heating element. They draw about 300 watts. You got to look at your the smaller ones are a little bit smaller, so you have to look at those. But once again, I know the watts is the number on top, divided by the volts, I get my amps, divide my amps into my volts, and I get my ohms. So you can test it that way. You can do an ohm test on those heating elements to see if they're good or bad. So one thing you want to be careful with is touching these leads. That'll give you a reading if you actually touch these leads together. But that's an M right there, that's mega ohms. So you have to be aware of that. But on a bad heating element, we're going to read that. So I've had technicians come up and tell me that their element's good, but what we're looking at is 1.3 mega ohms. That's not good. You can actually see the damage on this one. Okay. And then here's a good one. It's an old used one, but it's still good. And it's going to give us 10.5 ohms. Okay. And what we come up with in our formula was 10.3 ohms. So that's good right there. So if these are hard to get to, some of the old Atwoods were harder to get to, right to the back of the you want to make sure at least one of the wires is disconnected when you're reading these two. You want to make sure there's nothing else in the circuit that could throw off your readings. So you could do it at the circuit breaker by turning the circuit breaker off. But you have to make sure that that circuit is complete all the way to the heating element. So the ECO is not tripped, the thermostat's not tripped, the switches are on. Sometimes there's more than one switch. So you could check it right there. So once again, there's a good one, 10.5 ohms.